Everyone, welcome back to my channel. Today we're looking at physics paper 1 505412 and May June 2015. So let's begin. So question number 1 says which quantity is a scalar quantity. So we know a scalar quantity is a physical quantity that has only magnitude. So acceleration has magnitude and direction, force, magnitude and direction, temperature and velocity. It has to be temperature, because if we say that there is 2 degrees Celsius, then there is specific direction associated with it that can show that it's a vector quantity. There's only that one magnitude, which is 2 degrees Celsius. The diameter and the length of the thin wire, approximately 50 centimeter in length, are measured as precisely as possible. What are the best instruments to use? Okay, so most of the students, they get confused whether we have to use micrometer, screw gauge, or vernier caliper while finding the diameter. So there's one key. If it's specifically written internal diameter, only then you're going to be using vernier caliper. But if it says diameter only, then you're supposed to use micrometer. So these two options are already out. Now we're left with length. This is 50 centimeter in length, and we know a ruler can measure up to 1 meter. So we're going to be using a ruler. A vernier caliper can only measure up from 1 centimeter to 15 centimeter. A cyclist takes a ride lasting 25 seconds. The diagram shows how her distance traveled from the starting position varies with time. What is average speed? So what do we mean by average speed? We know average speed is total distance over total time. So now what is the total distance? 150. Total time 25. So all we need to do is divide this, and you're gonna get the answer 6. Moving on towards question number 4. A car begins to move. It speeds up until it reaches a constant speed. So whenever something reaches a constant speed, that means the resultant force is equals to 0. It continues to travel at this constant speed for the rest of the journey. What happens to the acceleration and what happens to the velocity of the car during the journey? So both the acceleration and velocity changes. Only the acceleration changes, only the velocity changes. So apparently, when the car starts moving, obviously this is a stated fact that it won't be moving at a constant speed from the very beginning. There must have been a change in the acceleration and velocity for it to reach a constant speed. That's why there was a change in velocity. Gradually, the acceleration decreases, velocity increased, and then there came a time when it reached a constant speed. So it has to be A. A metal ball of mass 0.3 kg and weight 3 Newton is held so that it is below the surface of oil. It experiences an upward force of 0.3 Newton. When the ball is released, what is its initial acceleration? So they have given me the mass, they have given me the force, and the most suitable formula that I can think of is F is equals to ma. So m is 0.3 kg. I need to find acceleration, and I need to have the force. So this F means the resultant force. The resultant force is the final force acting. There is 3 Newton downward, there's 0.3. I need to find the resultant force, which is going to be 3 minus 0.3. That's going to give me 2.7. And if I divide this, I'm going to get 9 as my answer. A student drops from rest a table tennis ball in air. What happens to the velocity and acceleration of the ball during the first few seconds? Pretty simple. So when you throw something from a very greater height, initially the only force that's acting on it is its weight. So there's only downward acceleration, resultant force is acting downward, but gradually the speed increases, the air resistance increases, and the resultant force decreases. So when the resultant force decreases, the acceleration decreases as well. I'm saying this over and over again. Resultant force and acceleration are the same thing. Whenever resultant force decreases, acceleration decreases. So speed increases and acceleration decreases. So this seems like C. Moving on towards question number 7. The Earth travels in a circular orbit around the Sun at a constant speed. Which arrow shows the direction of the acceleration of the Earth and the direction of the velocity? So this is, the force that's acting. So whenever something is moving in a circular orbit, the force that is acting on them is the centripetal force. So the resultant force is going to be here and the velocity is going to be here. So it looks like D. Question number 8. The mass of a stone is found on Earth using a pan balance. The weight is found using a Newton meter. And we know, regardless of the gravitational field strength, the planet you are in, that your mass remains the same, because mass is the amount of matter in your body. And that remains the same whatsoever. So it's going to be the same no matter what happens. But the Newton meter, the weight is dependent on the gravitational field strength. So as the gravitational field strength changes, the reading on the Newton meter also changes. So it's going to be B. Moving on towards question number 9. A uniform beam is pivoted at its center. Two weights are placed on the beam in the position shown and the beam is balanced by an upward force F. What is the size of F? Pretty simple. So when two things are balanced, the arrows have to be pointing in the same direction, but there's this one arrow which is acting in the upward direction. That means it is totally opposite of this one, so we have to kind of subtract it. So we know since these two are balanced, we have this side as 40 into 30, which is going to give me 1200, and this side should be same, but there's this bigger force acting on this, so we're gonna be, this is like the final big force, it's gonna be 50F, right? So it's gonna be 50F minus 1800, because this is a bigger force, this is a smaller force, so we have to subtract the smaller force from the bigger force. So this is the bigger force, so we're just gonna solve this and you're gonna get your answer as 60. The diagram shows liquids in containers. Which column of liquid exerts the greatest pressure on the base of its container? Okay. Pressure is equals to force over area, or I can even talk about density is equals to rho GH. And so you're gonna see the greater the density, obviously the greater the pressure, so they have the greater density. And again, it depends on the amount of liquid as well. So the greater the height, the greater the depth. So the greater the depth, the greater the density, the greater the pressure. So it's gonna be B. Because there's more liquid, it's narrower, that means more pressure is acting at its base. Moving on towards question number 11. The graph shows how the pressure of a fixed mass of gas varies with volume at constant temperature. What is the volume of the gas when the pressure is 25 kilopascals? I said this in one of my previous videos as well, that whenever it's about the pressure of gas, there's only one formula. P1 V1 is equals to P2 V2. What is, so they're asking me about 25 kilopascal. I can take 25,000 and then V2. I can have any value from here. I can have, let's say, 100 kilopascal. I can have 100,000 into 10, and when I solve it, you're gonna see the answer you get is this. Question number 12. A rocket of total mass m is traveling at a speed v. The engine of the rocket is fired and the fuel is used up. The mass decreases to m half and the speed increases to v. What happens to the kinetic energy? So what do we know about kinetic energy? We know 1 over 2 mv square, and kinetic energy, when mass decreases and kinetic energy, speed increases. So you can see the mass decreases. So when the mass decreases, the kinetic energy doubles, but the speed increases too. So it doubles again. So it's going to be 4. So once it doubles when the speed decreases, and then it doubles again when the speed. Once it doubles when the mass decreases, and then it doubles again when the speed increases. So it increases by a factor of 4. A builder lifts 8 slabs from the ground on the back of a lorry 1.5 meter high. The time taken is 48 seconds and each slab weighs 200 Newton. How much useful power does the builder produce? Okay. So they're asking about useful power. We know power is equals to work done over time, or energy over time as well. And so what we need to do is find work done, right? And the work is forced into distance. So it's going to be 200 into 1.5 over 48. Let's see what the answer is. 200 into 1.5 divided by 48, and we have to multiply this because they're saying 8 slabs, and each one slab weighs 200, 8 slabs weighs 1600, and you get 50 as your answer. A solid bar is heated at one end. How is thermal energy transferred to the other end of the bar? Since it is solid, it's going to be through conduction. Heated molecules move along the bar, carrying energy to the other end. No, heat molecules vibrate. They do not move. They only vibrate. Solid particles, they do not move around. They can only vibrate about their fixed position. This is D. Moving on towards question number 15. An electrical heater is placed in a beaker of cold oil as shown. The heater is switched on. What happens to the liquid at X? So when it is switched on, the water above this, it gets heated up and it becomes less dense. So it becomes less dense and rises. The tubes inside solar heating panels use the sun's radiation to warm water. Why are the tubes painted black? So we know black is a good absorber and emitter of light. So black surfaces, they absorb radiation well, and black surfaces conduct heat well, black surfaces emit radiation well, and it's gonna be the reason, since they're absorbing, this is right as well, this is not wrong, but they're asking why are they, we're talking about solar panels, they're absorbing the sun's energy, so we need to talk about the absorption process here. Question number 17. This wasn't a part of 2023 syllabus, so we're just going to skip it and move on towards question number 18. Which substance in the table is liquid at 20 degrees Celsius? Many students, they find it confusing to find the state at the given temperature, so I'll make it easy. We're going to make a number line. I'm going to write melting point here, and then I'm going to write boiling point here. So I know after this, it's going to be liquid here. Here is going to be a gas, and here is going to be a solid. So if they're asking me about 20, and if the melting point is minus 218, and minus 218 is going to be way here, right? So if it's minus 218 here, and boiling point is minus 183 here as well, it's going to be a solid. Okay, so for B, it says minus 39 is the melting point. So if I put minus 39 here, and if I put 357 here as its boiling point, on the number line, 20 is going to be somewhere here, right? Because in a number line, you go 0, minus 1, minus 2, minus 3 on the left side, and on the right side, it's 0, 1, 2, 3, 4, 5, 6, 7, and so on. And so it's going to be liquid here. So it's B. Which diagram represents the change in the arrangement of the molecules in a solid as the substance melts? When a solid changes into a liquid, the particles, they can only slide over each other. They do not have the full authority to move around randomly. And in solid, they're obviously vibrating. It's going to be A. Some gas is trapped in a closed container. The gas is cooled, and the volume of the container is... This is a very important piece of information in these type of questions. When the gas is cooled, they collide with the walls more often. No. They contract. No. They can never contract. Molecules themselves never contract or expand. They get closer together. Yes. Reason being, it's because in a container, when you have particles moving around and you're not changing the volume as well, they, when you're cooling them down, they lose energy and they come closer together. Moving on towards question number 21. In liquid, some energetic molecules break free from the surface even when the liquid is too cold. This is evaporation. Because if it was boiling has to have a specific temperature, like 100 degrees Celsius for water. It doesn't just occur at any temperature. A pupil adds 37 gram of ice at 0 degrees Celsius to 100 gram of water at 30 degrees Celsius. The final temperature of the water and melted ice is 0 degrees Celsius. No heat is lost to or gained from the surrounding. The specific heat capacity is 4.2, and specifically the heat defined, we have to find that out. Pretty simple. So let's do it step by step. We have two things. We have water and we have ice. But the energy which is going to be emitted and transferred is going to remain the same. So let's start off with water. They have given me specific heat capacity. I know C is equal to Q over M delta theta. I know C 4.2. I do not know Q, but I know mass, which is going to be 37, and then the delta theta. Okay, so since we're talking about water, mass is going to be 100 gram, and then change in temperature is 30, and then you're going to get 12,600 as well. And this is going to remain the same for ice as well. The specific latent heat of ice is going to be capital LF is equals to LF into M, and this is energy. So we know M is 37 gram of ice, and I need to find specific, and I have the energy here, 12,600. When I divide that, I'm going to get 341 as the answer. You just need to make sure that the Q, which is the energy, and LF is the energies as well. And the Q, it remains the Q emitted or absorbed remains the same. The heat capacity of an object of mass 2 kg is C. The energy needed to increase the temperature of the whole object by T is CT. Yes. A ball floating in a rippled tank begins to move vertically up and down as a wave passes beneath it. The ball does not move horizontally. Both energy and water, no, water is not transfer. Energy is not transfer, energy is transfer, energy is transfer. It's really important to read the whole statements and read all of the statements given options, because you have to then cross out the one that you think are not the answers. 25. A ray of light in glass is incident on the surface of at an angle C. The angle C is the critical angle, which diagram shows what happens to the light. Okay, so it's pretty simple. They're saying the angle C is critical angle. This one, when something is critical, when the angle of incidence is equal to the critical angle, then the light, the angle of refraction is 90 degrees, and some of it is, really little of that light is also undergoes total internal reflection at the same time. This shows that it is refractive, which is totally wrong as well, because it is critical angle. Now this shows that it is 90 degrees, and some of it is, as I said earlier, undergoes total internal reflection, so it is D. A ray of light is incident on the surface of a glass block as shown in the diagram below. The refractive index is 1.5. The light ray changes direction when entering the glass. What is the angle x through which the ray moves? There's one thing that most students do is that they take this angle instead of taking this one. When we have to take this angle, because angle of incidence is the angle that the ray makes with the normal. So this is the normal. So it's going to be 45 as well. And since the refractive index is 1.5. So what do we know about refractive index? Refractive index is n is equals to sine of angle of incidence over sine of angle of r. It's 1.5. Sine of angle of incidence is going to be 45 over sine of angle of r. And when you solve that, sine of 45 divided by 1.5, shift sign, answer, you're gonna get 28.90 minus answer, it's gonna give me 62.26. So when you solve this, you're going to get 28.1. So now 28.1 is this angle. I need to find x. So I'm not gonna subtract it from 90. Reason being, it's because this whole is gonna be 90. So when I subtract it from 90, I'm gonna get this whole angle, but I just need this one. Now you can see that this is some sort of like this. So vertically opposite angles, 45, 45. When I subtract 45 minus 28.1, I'm gonna get 16.8, which is equal to 70. An image is formed by a thin converging lens when it is used as a magnifying glass. What is the correct description of the image? So it's going to be virtual and indirect. There's this whole table made in the book. You can either learn it through grid or VUM. Real and inverted diminished, virtual upright magnified. Moving on towards question number 28. Which component of the electromagnetic spectrum is used for television transmission from satellites? Microwaves. In which situation do sound waves not travel? They do not travel in vacuum. From a satellite in space to Earth, yes. Two sound waves X and Y are compared. X has a greater frequency, that means louder pitch. Greater amplitude, that means it's louder. How do the loudness and pitch of sound wave compare to those of X? Y is louder and lower pitch. Moving on towards question number 31. A metal ring screens a piece of equipment from a magnetic field. Which metal should be used for the ring and why? It is always the reason why we use iron for shielding is because it is a good conductor and it helps strengthen the magnetic field as well. A positively charged rod is brought near to an isolated, uncharged conducting sphere. What are the charges on sides X and Y of the sphere? Since it is not earthed, there is not going to be any flow of charges. So everything, the flow of charges is going to be constricted to this circle only. If it is positive, it's going to be negative, negative, negative here. But it's not going to be negative all around the circle. They're going to be positive, positive, positive here. Both X and Y, X is negatively charged and Y is positively charged, yes. Moving on to question number 33. The diagram shows a circuit where must an ammeter be connected to measure the smallest current. Okay, so to me it looks like C, and most of you must be thinking it's B or a D. Okay, so if you connect an ammeter here or here, this is gonna measure the highest current because total current goes from here, divides, and then gets it gets the same value. If you're starting off with 20 ampere, you're gonna get 20 ampere here as well. But you see, in parallel, as you keep on adding more resistors, the total resistance decreases, and so it's gonna be C because this is total greater resistance. Two resistors of resistance 30 ohm and 60 ohm are arranged in parallel. The current in the 30 ohm resistor is 0.6. What is the potential difference across the 60 ohm resistor? So since these two are in parallel, the potential difference, it remains the same. So if I can find V through these two, if I say V is equals to YR, so now I have to find V because that's going to remain the same. I is 0.6, R is 30, and when I solve that, I really need to buy a new calculator. 0.6 into 30 is going to give me 18. So it's going to be 18 here. So now 18 is equals to I. Oh, you got the answer. The circuit shows 3 resistors in series connected to a battery. Each resistor has a voltmeter across and 2 of the voltages are shown. What is the potential difference across the resistor R? Okay, so since these are in series, the simplest thing, in series the current remains the same but the volt gets divided, but the total volt, if it's starting off as 40 here, it's gonna end up as 40 here as well. So that's giving me 2 volts. It's gonna be 28. 40 minus 28, and then it's gonna be 12. Pretty simple question. Question number 36. A teacher moves a magnet into and out of a coil of wire as shown in order to demonstrate electromagnetic induction. Which statement is correct? As the magnet moves into the coil, the left hand of the coil becomes a south pole. Oh, so there's this one law that if I'm moving north pole in this direction, it's gonna develop a north pole here so that it can oppose its cause, because this is what Lenz's law states, that it always opposes its cause. Increasing the speed at which the magnet enters the coil increases the induced voltage. Yes. A transformer consists of two coils that are wound onto a metallic core. Which type of voltage is supplied to the transformer? Which metal is used? Always iron and alternating. A nucleus of 215-84 emitting an alpha particle then decays by emitting a beta particle. What are the nuclear number and proton number? Pretty simple. So there are two equations. If I have XAC, if it's emitting alpha particle, it's gonna get XA minus 4 Z minus 2 proton number, atomic number, plus HE42. And then I'm gonna have for beta particle, it's gonna be XAZ and then XAZ plus 1 plus E0 minus 1. So right now, if it's emitting an alpha particle, it's starting up as 215. 215 minus 4 is going to give me 211. And then 84 minus 2 is going to give me 82. And then it's emitting a beta particle, so it's going to be 83. So it's going to be 211 and 83. Moving on to question number 39. A radioactive material decays by this process. What is particle X? Oh, it's an electron, because you know this equation is for beta particle, and beta particle emits an electron. Alpha particle emits helium particles. So it's going to be an electron. The half-life of a radioactive isotope is 24 hours. A sample of this isotope produces an initial count rate of 72 counts per second. How long does it take to fall to 90? If it's starting up at 720, you half it, you get 360, half 180, half 90. How many lives are there? 1, 2, 3. Since there are 3 lives, 24. Since 1 is 24, 24, 24, 24 to 3, 72, and you get your answer. So this was question number 40 and the end. So don't forget to subscribe my channel, and if you have any problem regarding any question, leave a comment and it won't be left answered.